Hello and welcome back to part 4 of the small series of videos on the topic of sampling from the e-learning from Q-Interline. In this video, I will cover taking a spectrum, which may seem trivial, but there are so many ways of taking a spectrum that it can be done very good and very bad. The entire effort of making a representative sample, taking out the right samples in time, presenting it well to the analyzer may be completely lost if our settings of how we acquire the spectrum is not done correctly. So spectral quality becomes the last standing barrier before we have a real good solution. What is spectral quality? Well, spectral quality, in my opinion, is a low noise spectrum that contains all the needed small features, shoulders and peaks, allowing us to build the application that we want with the required accuracy, agreement, precision, and not biased. That's good performance. The first thing we want to look into when we take the spectra is what kind of a spectral range do we need? We do have systems that covers quite a range. Some of them cover all of the range, but there are typically multiple detectors. For at-line, it's a little bit easier because it may be easy enough to cover the entire region, but what about online? Will the light be transmittable in an optical fiber in a certain region? What region should I choose? Generally speaking, detectors with a narrow band may be more sensitive, whereas broadband detectors are slightly less. Nowadays, there are good combinations, and a quant will typically come with an InGaAs 2.6 or an InAs detector covering the entire region quite well, but just there might be other things limiting the spectral range. Let's look at a typical spectrum. In this spectrum, we can observe two things. The two spectra shown here are both of barley kernels. Barley kernels, we would typically want to see protein, moisture, and the salt. One is taken at 4 wave number resolution, 2 wave number data point spacing, the other one at 32. But this whole thing on resolution is a little bit tricky. You saw that they both look identical, but we may have things to consider. Quite many instruments offer a fixed resolution, whereas the instruments from Q-Interline have a variable resolution. It can be set 2, 4, 8, 16, 32, or even 64 wave numbers. Bands in the near infrared are not very sharp, hence we do not necessarily have the capability to resolve the peaks no matter what, because nature has flattened these peaks. So be very careful not to over-resolve or try to, because an FT instrument will respond with fairly noisy spectra. So keep a decent resolution, typically to the conservative side. My favorite is 16 or 32 because I get very low noise, and you may be tempted to say I want to have a lot of data just to be safe, but in this case I would say here more data is not safe. It's actually here it means you're sorry. Let's go back to the spectra and observe this. Quite often when we build a calibration model, we would want to do pre-processing. If we look at the next slide, here I've shown you a Savitzky-Goulet second order with 7 smoothing points. The 32, what we could call the not so nicely resolved spectra, becomes the green spectra here. Lots of nice noiseless features, whereas the 4 wave number resolution spectra simply explodes in noise. If we want to work with 4, we would have to scan for a longer time or do other tricks. This is typically something not seen when we build the model, and we would add a lot of smoothing to the blue spectrum in order to get back to the green, and then what's the point? So be careful with resolution. It's not necessarily the easy thing to come around. Then it comes down to observation time. how many scans should I do? Well, for accessories spinning around, you need to do one full circle. Because otherwise, if you only do half a circle or you do 1.5 circle, then half the sample gets twice the saying. So a good rule of thumb is you need to scan enough for your signal to noise to be low enough. Signal to noise will translate into repeatability. Once your repeatability is good enough, lower the number of scans until repeatability is just good enough. The rest is just waste of time. So I would say, generally speaking, anything 5, 10, 15, 20 seconds is normally enough, but you may as well do it as quick as possible. There is no feeling good. If it has taken a round, you have taken a round, and that's all you can get. If you want to do more, you have to take 2 rounds because you want to have the entire sample having the same saying. Otherwise, we do delimitation errors in the scanning section of our work. So in summary, scanning and taking spectra is all about making sure you see the relevant spectral region. Make sure your resolution is good, not too good. Don't get greedy. Make sure that the spectrum has a very good signal to noise, relevant for your application. And remember that with high quality data, spectral-wise, sampling-wise, reference data-wise, reference analytical-wise, it's simply easier to build models. So thank you for listening in to these 4 small videos on sampling. I hope you found it useful, and I hope these insights in sampling may improve some of your work. And remember, awesome spectroscopy rocks. Thank you.